this one is an example. They want us to test convergence of this series. So this one you can see there's a power on that arctangent that would indicate that root test might be a good one to try here. So if we're going to do this with the root test, we want to see what's the limit as n goes to infinity of the nth root of this series. Okay, and so what this is going to be if we take the nth root of both the numerator and denominator, then that means we got the nth root of 1 here. On bottom, if we do the nth root right here of something to the n power, those are just going to cancel each other out. So this would end up being just arctan of n. And on top there, if we got the nth root of 1, no matter what root you take of 1, that's just going to equal 1. And so all this ends up being is that. So now if we know what does the limit as n goes to infinity of the arctan function, what does that equal, then we should be able to figure out what this is going to be. Let's use our calculator to see that. So I'm going to go on my calculator, already got arctangent function entered there. If you graph it, you can see what the picture of this one looks like. It looks like this. What's that approaching as we go to infinity? I'm going to use the table to do that. So let's go to table settings. Let's start this at like say 10,000. Should give us a pretty good estimate there. So now I'm going to go to my table. And it looks like this is equaling 1.5707. What's that trying to approximate here? So 1.5707 is our approximation. I know this is talking about an angle if we're doing inverse tangent or arctangent here. So if it's an angle in radians, that means pi is a part of that. I'm going to divide out our pi here. Looks like that is trying to approximate 0.5, which if we have 0.5 with pi divided out of it, that this limit here, limit as we go to infinity of our tan here is equaling pi over 2 or 1/2 pi. So that would be what this one's equaling here. So now our limit here, I don't need the limit notation anymore because we know this is approaching pi over 2. But what is this going to be equal to? We could either enter it the way it is. I could also multiply by reciprocal here. So this would be the same as 2 over pi. I don't really know what 2 over pi is actually equal to, but I don't need to know. I know pi is about 3.14, so if I took 2 divided by 3.14, that's definitely going to be something less than 1. And for root test, that's what we want to check. Is it bigger than 1 or less than 1? If it's less than 1, that means we have a convergent series by root test here. Because it ends up being here less than 1. All right, let's try another one. Test this series. Again, I see that we have a power of n here, so root test might be a good one to use. So let's do limit as n goes to infinity of the nth root of what we got here. All right, so if we take the nth root of both top and bottom here, the top becomes easy. The nth root of 3 to the n, the nth root and the power of n cancel out. That's just going to make that plain old 3. On bottom, we got the nth root of n to the 3rd power. So how do we simplify something like that? Well, this one. I also know another way to write that would be equivalent would be that this would be the nth root of n all to the 3rd power. What is the nth or what is the limit as n goes to infinity of the nth root of n? This one I'm going to kind of do as a sidebar here, and this is one that you should kind of take with you and know for the future. So what we're going to do is we're going to say, what's the limit as n goes to infinity of the nth root of n? What does this one come out to equal? I'm going to start by writing this instead as n to the 1 over n power, because that's what it means if you're taking the nth root of something, you're doing it to the 1 over n power. Now what I'm going to do is use a little trick with exponentials and natural logs here. I'm going to write this as e to the natural log of n to the 1 over n. And this should be equivalent, because remember, if you have e to a natural log, those are opposites. Like if I have e to the natural log of x, that would just equal x, because e and natural log are opposites. They would cancel out, so it just equal x. So I'm just using a little trick here to do that. And the reason I did this little trick is now that we have natural log here, I can take advantage of natural log properties and move this down. Okay, so now what I have here is we're going to be doing, and I'm going to, since this is a function to our e doesn't really have a play in this, I'm going to write our limit now up here. N goes to infinity of 1 over n natural log of n. Another way I could also write that would be limit as n goes to infinity of natural log of n over n. So what's that limit going to equal? Well, right now, both of these two functions would be going towards infinity. If I got infinity over infinity, that's an indeterminate form. I'm going to want to use L'Hopital's to figure this out. So using L'Hopital's here, this would now be, take the derivative of both the top and bottom, so derivative of the top would be 1 over n, derivative of the bottom would be 1. As we go to infinity now, that's going to go to 0. And so if that goes to 0, then this whole thing would equal e to the 0 is equal to 1. And so this is one you can just kind of assume, and AP's okay with you just saying that this is true, is that if you do the limit as n goes to the infinity of the nth root of n, that's known to equal 1. So you can just use that as a known thing from now on, that if you're doing a problem and the nth root of n comes up and you're doing that limit as n goes to infinity, it is equal to 1. You don't need to go through this whole showing all this e to the n, e to the ln stuff again. Just know that it's always equal to 1. So let's jump back to our problem now. That means the limit, or our limit here as we're doing this, I don't need to show limit anymore, that this would be equal to 3 over 1 to the third power. Well, 1 to the third power is 1. 3 divided by 1 is going to be 3. So this limit comes out to be 3. That is greater than 1, and so this one is divergent. Anytime the limit comes out to be greater than 1, it's divergent by the root test here. So this is an example of one that would be divergent. All right, we've done a couple here. Let's have you try one. Pause the video and see what you get for this problem. All right, apply the root test, because you can see this is all to the power of n here. So if we did the limit of the nth root of this series, those are going to cancel out. So it just becomes this limit here. We can evaluate this one by multiplying by 1 over n to both top and bottom. That's going to go to 0. That's going to go to 0. So we get 2/3 as our limit answer. That is less than 1. So we know if whatever we get becomes less than 1, this is going to be convergent by our root test.